All right, this next example, I'm calling an advanced example, but I think it's an important one to go ahead and record a video for and take the time to kind of explain to you, kind of what I have written down. And the reason for that is, um, the previous examples with histograms, those were textbook examples with data, that looks nice and works out nice. What do you do when you start working with real world data that's measured and has decimal places of accuracy? How do you kind of wrangle in some of those rough edges, some of the squirrely nature of nature? How do you wrangle that in and still create a histogram? Okay. So that's what this example is meant to give. And I'm kind of putting some extra thoughts into how you choose starting points and things of that nature. So let's kind of get into it, and I'll just explain things as I go along. So here we're talking about the pH of precipitation or the acidity of rain. Okay. Um, so the pH of water collected from 26 precipitation events in Allegheny County, Pennsylvania, between December 20th, 1973 and May 23rd, 1974 were recorded. So design two histograms with the recorded data set. So here's our data set of acidity level found in rain in Pennsylvania between these two dates. So notice right away, these are all measured values. These all have two decimal places of accuracy. In some cases, you have values like this one, 4.4, and it appears it has only one decimal place of accuracy. So if you remember, step zero, was to kind of look at your data, and number one, figure out what your sample size is, and also what the maximum number of decimal places you have. So maximum number of decimal places that you have. Well, we have some datums that have one decimal place and all the others have two, right? For example. So our value of D for the maximum number of decimal places in our data set is going to be two. And that's going to come into play later, all right, when we calculate the width of the classes in our histograms. So right away, this would be kind of a complication and may stop a student from trying to make a histogram right off the bat, is just that difficulty. Now the sample size, we could just count each of these, but we're kind of told here that we're dealing with 26 of them. All right, so that would be step zero. Now step one is to find a starting point for class one. So now that we're dealing with some real world data, we need to maybe consider the data itself. And so two considerations are, question one, what is pH? Question two, what are the starting point options? So in answer to question one, what is pH? pH refers to the acidity of a liquid on a scale from 0 to 14. So an acidity level of 0 is highly acidic. So a pH value of 0 is highly acidic. I think the human stomach has a pH of 2, if memory serves correctly. I might be wrong. A pH level of 7 is neutral, and a pH value of 14 is highly alkaline or basic. So that's what we're dealing with. Now, the reason why I mention that is because we're dealing with a pH scale, we might want to have 0 as a starting point because that would be a natural value that's highly acidic. So just kind of keep that in mind. Question two, is what are our starting point options? So let's look at answer two. Let's look at our starting point options. So like I just mentioned, it might be a good idea to start with 0 as our starting point because 0 is on the scale of acidity levels. So it might seem natural to start a histogram at 0 and end at 14, right? So it might be natural to have our histogram start at 0 and end at 14, and have some class bars here that does something like this. But if there are 14 classes or 7 classes, then each class will be only 1 or 2 wide. So if there were 7 of these, then in order to cover this, each class is going to have to be 2 wide. Well, that's going to cause a problem because all of our values were either 4 point something or 5 point something. So what that means is that let's say this middle class, let's say class 3 went from 4 to 6 because that's a width of 2. Well, all of our data is going to be in this class, and we'll only have 1 bar. The other classes won't even be present. They'll all have frequencies of 0. So we're going to have a histogram of only 1 bar, and so that's not a good idea. So therefore, starting our histogram at 0 is not a good idea. Sometimes, based off of your data, it might be a good idea, but in this case, it's not. Kind of looking ahead and thinking about it, it's not going to be a good idea. Okay, option 2 is to choose a starting point of 4.0. So why 4.0? Well, look at our minimum number. It's 4.12. So we could choose a value that's lower or less than our minimum. And 4.0 fits that bill. So the human brain likes to see nice whole numbers. In addition, 4 is not a datum value. So figuring out if the lower bound of class 1 includes or excludes 4 is not a consideration. This is certainly an option that will work with any calculator or any software. Okay, so option 2 could be a candidate we could use. Option 3, let's choose as a starting point 4.10. So this is similar to option 2 that we just had. This is certainly an option that'll work with any calculator or software. Option 4 would be for our starting point to be equal to our minimum. Right? So if we look up here at the top, 4.12 is our minimum value. And so we could choose a starting point that's equal to the minimum. Okay, so since 4.12 is a datum in the data set, then care is required to choose the correct interval for class 1. An interval with the lower bound included is needed. So class 1 will have to be designed this way, where the lower bound includes 4.12. Now, this starting point would work with Texas Instruments and NumWorks calculators. It would even work with Microsoft Excel, but Google Sheets will not work because Google Sheets uses a lower bound excluded format. If you chose 4.12 as a starting point, Google Sheets would not include 4.12. And you would be leaving out this data. Okay, so this one is questionable as to whether you would use it. I would say yes, if you're using your calculator or if you're using Excel, but no if you're using Google Sheets. Okay, option 5 is using the OpenStax method. But I'll just kind of leave that and let you kind of read this if you want to know a little bit more about that. Okay, so for this example, I'm going to choose a middle ground. I'm going to choose option 3, which is going to be a starting point of 4.10 with class intervals organized this way. So what's nice is that 4.10 is less than 4.12, which is our minimum datum. So because I'm choosing 4.10, this is going to work with Texas Instruments. It'll work with NumWorks. It's going to work with Microsoft Excel, and it's going to work with Google Sheets. So choosing this starting point is going to ensure it's going to work no matter what. Okay, I'm going to be fine. So now we can move on to step 2, and that's to find the range. Okay, so the range is equal to the maximum minus our starting point. Okay, well, our starting point is 4.10, and the maximum, again, we can come up here to the top. So these datums were arranged in ascending order. So the last one is the maximum, 5.78. So I'm going to put 5.78 for the maximum. So this is my range, 1.68. Step 3 is to find the number of classes and the class width, and we're dealing with a sample size of 26. So remember, we've got these two methods for calculating the number of classes, the OpenStax method and Sturge's formula. And you can see here, we get answers that are 5 and some change, right? But remember, the rule is you want to round down the lowest k. Well, between these two, which is the lowest one? It happens to be this one. So we're going to round it down to 5. And then we take the other one, which is the highest, and we round it up. So 5.697 will just get rounded up to 6. Now we round this up regardless. Let's say this one came out to be 5.2. Okay, 5.2 is still larger, and we would round it up. So we'd still round it up to 6. Okay, so just to be clear. So histogram 1 is going to have 5 classes, and histogram 2 is going to have 6. Okay, now we got to figure out the width of each of these. And now this is where that special rule is going to come into effect that you didn't see in the previous examples. All right, so we need to use this inequality. K times W has to be greater than our range. And so our lowest number of classes, we're calling that K low, and that's equal to 5. And our range from up above is 1.68. Divide both sides by 5. And 1.68 divided by 5 gets us 0.336. All right, so notice what's going on here now. This value of W is less than 0.9. So we need special rounding. So because this value of W is less than 0.9, we need to think about our value of D, the maximum number of decimal places, which was 2. So now we want to look at the second decimal place, second because D was equal to 2. And the second decimal place is this 3 right here. So we're going to round this 3 up to a 5. And so the width is going to be 0.35. So histogram 1 is going to have 5 classes, each that are 0.35 wide. Okay, histogram 2 is going to have 6 classes. So we use the same inequality that we just used. Substitute 6 in for K high, substitute in our range, divide both sides by 6, and now we get a width of 0.28. Now 0.28 is less than 0.9. So like just before, we need to do our special rounding. And again, because d was equal to 2, we want to look at the second decimal place. And because it's an 8, we're going to round that 8 up to a 10, which means we're going to put a 0 in the 8's place and carry the 1. So we're going to carry the 1 over, and the 2 will become a 3, and where the 8 was is a 0. So that rounds up to 0.3. So histogram 2 is going to have 6 classes, each that are 0.3 wide. All right, so this is something that I haven't shown yet in an example, is how to round up the width based off of the width being less than 0.9. And this example shows you how to round up to 5 and how to round up to 10. Okay, so I kind of summarized here. Histogram 1 is going to have 5 classes, each that are 0.35 wide. And histogram 2 will have 6 classes, each that is 0.3 wide. So now we need to create a frequency distribution table. So this is where your calculator is going to come in handy, right? Because you can't easily add 0.35 in your head, and you can't easily add 0.3 in your head, okay? So histogram 1 has 5 classes, so we're going to label this 1 through 5. And the starting point is the lower bound of our first class. So the starting point was 4.1. And we want to fill in each of these values by adding 0.35 each time. And then using your calculator, go ahead and take this list and add 4 to it to fill out this list. You see where the calculator can be a huge advantage here? And then for the midpoint, this is where you want to take the average of these two lists. So to get the midpoint, you'll take the lower bound list, add the upper bound list to that, and divide it by 2. Don't forget to put parentheses around the numerator. And that'll give you your midpoints here. Now, your calculator can get you these frequency numbers for you. But if you still wanted to be able to do this by hand, now you can start calculating these frequencies yourself, actually. So remember that the way that we're defining the intervals is by including the lower bound and excluding the upper bound. So we're going to start at 4.10, which would be here below 4.12, up to, but not including, 4.45. So I'm going to try and find 4.45. It's not going to include it. And so the frequency in this first class is going to be all of these datums between 4.10 here and up to, but not including, 4.45 there. This is class 1. And so if I did this correctly, we're going to have 2, 4, 6, 8, 10, 11 datums. That's why there's a frequency of 11. Okay, the next class is going to include 4.45, but not include 4.8. So it's going to include 4.45 and not include 4.8, which would be right there. So we're going to have 1, 2, 3, 4, 5, 6, 7, 8, which gives us a frequency of 8. All right. So I'm kind of parsing the data set this way. Down below, I kind of defined what each class was. So it might be instructive for you to kind of look and see how I defined each class using interval notation. And then I put the values that actually fit within each class here off to the side. So, the number of datums that were in this interval was 11. The number of datums that were in this interval was 8. The number in this interval was 2, 1, and 4. That's these values here. Okay. So that's kind of where that came from. Um, and then for histogram 2, I just did the same thing. So creating this frequency distribution table. Now we're dealing with 6 classes, each that are 0.3 wide. Put in 1 through 6 for class number. The starting point is the lower bound of the first class. Add 0.3 successively to each row, to each class. Then use your calculator to add 0.3 from this list to make this one. And then for the midpoint, it's going to be the lower bound plus the upper bound divided by 2. And that'll get you all these values. And then from this table, you can say that class 1 will include 4.1, but not include 4.4. So it includes that, but does not include that. And that's what I put down here for class 1. And so class 1 would include all of these values, which comes out to be 9 of them. Class 2 goes from 4.4, includes 4.4, but does not include 4.7. So it would include 4.4, but not include 4.7. And there's the same number. There's 9 of them. And that's where 9 and 9 comes from. Okay. So I just kind of went through. You can kind of look at this a little more carefully, but I want to try and keep this video as short as possible. Yeah, so now I just went ahead and graphed it using the calculator. Here you can see this is the screen from the NumWorks calculator where I've got a bin width of 0.35 and it starts at 4.10. Okay, and that's this histogram. For the second histogram, it has a width of 0.3, again with a starting point of 4.1. And this is what that histogram looks like. Okay, so what made this example special was 3 things. The first is all of the special considerations you really need to give to step 1 here. Okay, step 1, you really have to make a lot of special considerations. And I tried to put all my thoughts on paper as far as all the different considerations I would give to choosing a starting point here. And in the end, I chose to go with option 3, which was a starting point of 4.10, for the same reasons that I gave here for that option. The second reason why this was instructive was to give an example of, what happens when you have a width that's really small, right? When you have a width of 0.336, a width that's less than 0.9, how do you round it? Well, you have to remember what the maximum number of decimal points was in your data and go to that decimal place in your width and round it up. And in this case, we would round it up to 5. And so that gives us this width here. With the other width that we calculated, we got a width of 0.28. We need to go to the second decimal place. And because it's an 8, we're not going to round it up to 5. We're going to round it up to 10. So that means we're going to put a 0 in the place of 8 and carry the 1 over and make that to a 3. And that's where we got that. And the third thing, so that was number 2. The third thing that was helpful, I think, about this is to show the value of using your calculator, of learning how to use your calculator to fill in this table. Because you can get these weird widths, you can have a weird starting point, and it can be easy to make mental mistakes. Instead, use your calculator as a tool. Okay. And from there, you can use your calculator to get a graph and to get frequencies for you, right? So you can use it to get the frequencies and double check how you're doing things. All right. So I'll end this video here. Let me know if you have any questions.